Hi everyone, my name is Adam Absalo, and today I would like to share with you about the acid-fast bacilli staining, abbreviated as AFB staining. So in this staining, it has three reagents, and that is primary staining, decolorizer, and the counter staining. So today's presentation will be based on introduction of acid-fast bacilli. We shall see the ingredient of it, the principle behind, procedure, reporting, application, and last we shall see the limitation of these staining processes. So starting with introduction, the acid-fast bacilli staining, it was just meant purposely for identification of mycobacterium species, and this is because they have the unique cell wall structure, and it is not well identified by using this gum staining. So this is because they have a uh, thick wax material that they resist staining, but also they resist decolorization by strong acid such as acid alcohol. So this phenomena of being resistance to be decolorized by strong acid, it is known as make them to be known as acid fast, and it was just discovered by two scientists, that is Nielsen and Zill, in 1881. So those are just a short history on acid-fast bacilli in staining. So let us go and see the ingredient or the content of this acid-fast bacilli staining. So as in the first part, as I've said, that the staining, it comprises of three parts, and that is the primary staining or primary dye, the colorizer, and the counter staining. So in the primary staining, it contains the carbofuchsin, which it is 1% carbofuchsin, and this, it is a strong carbofuchsin as compared to the carbofuchsin which it is used in gram staining, and this is because of the complexity of the cell wall of this mycobacterium species. This makes them to be used strong carbofuchsin so as to allow the penetration of this carbofuchsin and aid in identification of this mycobacterium species. But also in this carbofuchsin inside, it has phenol, which acts as a mordant to enhance the staining processes of this carbofuchsin. But also we have the colorizer, which it is 25% commonly used, 25% sulfuric acid, and or the acid alcohol, and this acid alcohol just a mixture of equal part of acid and alcohol. So here we can just use a 3% of hydrochloric acid and 95% of ethyl alcohol to make acid alcohol for the purpose of decolorization. But last we have the counter staining, which it is a 0.1% methylene blue or malachite green, and this they are meant purposely for staining the background, but also those which are non-acid-fast bacilli, they retain the color of this counter stain. So for the case of methylene blue, they will appear blue in color for the case of those which are non-acid fast bacteria. So the principle behind the acid fast staining or AFB staining is based on the complexity and nature of the cell wall of this mycobacterium species, that the presence of large mycoric acid and lipid cell wall, which make them to be impermeable and make them to be hydrophobic in nature. So here, in order to break down these characteristics and allow them to be stained, we have this carbofuchsin, which inside in it we say it has the phenol which acts as a mordant, but also this carbofuchsin, it is a basic carbofuchsin which interacts well with the cell wall of this acidic part of cell wall of this mycobacterium species. But also the presence of heat allow to dislodge those wax material, to allow this penetration of this staining, and therefore to stain the required part. But also the use of this acid alcohol also allow them to dislodge the wax material and allow the stain to penetrate and make them to stain well those acid-fast bacteria. So for the case of those which acid-fast bacteria will take up the red color of the primal dye, which is carbofuchsin, and therefore they'll be stained as red in color or pink in color, depending on your visualization. So you can see red or pink color of those acid-fast bacteria. But for the case of non-acid-fast bacilli, they may take up the methylene blue color and may appear bluish in color. So for the case of acid-fast bacteria or acid-fast mycobacteria, they will appear pink or red, but for those which are non-acid-fast, they will take up the counter staining color. And the procedure of staining of this acid-fast bacilli, we start by flooding with the primal staining, which it is strong carbofuchsin for 30 seconds. And the second step, we need to heat in order to dislodge those wax material or lipid material and allow the penetration of this carbofuchsin to the required area in order to stain. And the third step, it is to just decolorize. And for those which are non-acid-fast bacteria, the color will be removed here in the part of decolorization. So the fourth step is to just put the counter stain, which it is methylene blue for 30 seconds. This time it depends on the manufacturer of that particular stain, how it is state. So after just put there, and we shall see those which are acid-fast, they will appear pink or red like this one, and those which are non-acid-fast, they will take the color of the counter staining, which it is blue in color. So how do we report? So for the case of acid-fast bacilli, we just report by looking these rods, and they are pink as we see in this picture. So the grading system, it depends on the guideline that you use. For the case of WHO, you can just report +1 or +2 or +3, or you can just report the scant, depending on what guideline you are looking at or you are referring at, because every guideline has its reporting system by looking certain particular field and looking them and report as whether it is +1, +2 or +3. So the application of this staining, mainly it used for examination and identification of mycobacterium species, but also it used to differentiate between acid-fast bacteria and non-acid-fast bacteria. Also, it may used for identification of some fungi species that such as Sporidium species by using this AFB staining. The limitation of this staining, it can only be used to identify acid-fast bacteria. So and this is because that process of heating for the other bacteria, they can be distorted, so you can see well the structure of those bacteria after you may heat, because the time that it used to heat and the temperature that used to be applied to that particular organism, it may denature that structure of that particular bacteria. Thank you very much for listening. Welcome to the next